This conference will now be recorded.
We have discussed about string methods and string class. We had a detailed analysis on that. And also, we had discussed about that string thing, immutability, why it's immutable, and how it is useful. All the things we had discussed, and the methods also. And we are almost at the end of that discussion. Okay. So let's. Okay, let me open it. So, topic is about string. So after arrays, the next topic we were talking is strings, Scala string. Yes. We had discussed almost all the methods yesterday. I mean, day before yesterday. Replace trim. I hope we had discussed. Then split is also there. Hope we had discussed about split as well. When you apply split, all right, the split returns split will split the string into tokens, and that tokens are written in the form of array, and that's what we have discussed in the last class, right? So, and we had iterated it and printed word by word or token by token in the last class. Hope you remember that, right? So that's the idea about that. I hope you are good with split. And one thing is there is one other important thing about equals and equal. That is one more, and also compare to method also should be there in string. One more thing, there should be something called compare to. We had done up to split in the last session. There are a few more things. We will discuss that and we'll close it today. Then switch to the our collections, introduction to collections. So one thing is the few more methods which we need to discuss is split is done, and format is one method. We need to talk about format. That is one thing. So apart from that, compare to also. So I'll just talk about those two and this one. So compare to one more method in string which is very important. Right? There are two things. One is equal and the other one is compare to. Two methods were there. See, both are used in many cases. We use equals and we use compare to. We use both. Okay. What is the difference then? When you look at those methods, both appears to be same for us. Equals means comparing whether two strings are same or not. Okay, and returns a boolean value, whether true or false. Compare to, when you look at it, even that is also comparing two strings. But what is the difference? The difference is equals returns a boolean as compared to returns an integer. And if you look here, the example, see here, I have two strings. If S1 greater than S2, you get a positive value. And if S1 is less than S2, suppose two strings are there, S1 and S2. If string 1 is having, if it is greater than string 2, means what the value returned by compare to, what it will do is it will return a positive value. If string 1 is less than string 2, then you get negative value. If both are same, you get 0. So you need to understand this. This is very important. You got it right. So this important. These 3 points here are very important for us. Following set. These 3 are very important. What is that? It returns positive if string 1 is bigger than string 2, negative if string 1 is less than string 2, or whatever it is. And finally, what is that third one? Equal. When it is equal, it returns what's 0. Got it right? It returns 0. And this is very useful when you're comparing strings in many situations. Okay, this method is very useful. Similarly, equals. Okay, we'll just test it with small example here. We'll close this strings so that we can jump to the discussion of introduction to our collections. Let me just open the Eclipse. Meanwhile, maybe I have added few more examples for format. Here. You got idea about compare to, right? Equals anyhow I had discussed in even when I was explaining about case class we have seen applying equals method on case class objects, if you remember. Okay, that equals operator is used. Now we will check all that one by one. Okay? That operator, that method, and then also the equals method and compare to method. We will just try to explore these 3 methods, and then we'll quickly finish this discussion of format method. If you are a hardcore C programmer, then you know in C++, in C language, sorry, in C, we have something called format specifiers. And if you want to create something like a C kind of strings in Scala or Java, even this is there in Java as well, then we use this method called format. Now these are placeholders, this percentage D, percentage F are placeholders. And for every data, there is one format specifier. Or for every data type, there is one format specifier. And that is easy to remember. That is not something too difficult. For example, if it is integer, okay, the format specifier used for int data is percentile D. For a decimal, use something like percentile F or percentile LF also. Okay, LF for double and F for float. Okay, and also for string we use something like percentile S. Okay, for char we use something like character, single character. Okay, for character we use percentile C. These are format specifiers. Got it right? For long, generally, we use long integers. For long, they apply something like percentile LD, and for double, they use some percentile LF. I'm not sure if it is same here. I'm just giving you an idea. This F and D and S and C, I'm sure. LD, LF, I'm not sure. We just cross check it. Okay, just for for recording sake, just put it like that. Maybe if any changes were there, I will let you know on that. Okay. So if you look at this, this is so simple to understand. Integer percentile D. This floating point or decimal type percentile F and percentile LF. For string we use percentile S. And for character percentile C and long percentile LD, like this. Now if you talk about this format method, how can we use it is this format method, here we can apply this format specifiers here. Okay, and when you look at this example, this is so easy to understand. Meanwhile, my Eclipse starts, I'm just giving you a quick walk through these things. Okay. So you can see here we are just creating a string. These are percentile D books and cost of each book is percentile F. We are just creating a string here. with the format specifiers included inside this each string. Okay, and I'm taking two variables here, y and z. Now you can see on this string we are applying these variables, y, z. Now what happens is depends on this data. Y is integer, z is decimal, right, floating. So when you pass yz to this format method, what happens is if you are applying this format on this string x, observe here. Now what happens? This format, what it is going to do is it is going to apply these values yz in place of this format specifiers. You can assume these as placeholders. Something like what I have discussed with the string interpolation. So this acts as placeholders here. So in place of percentile d, that integer value is substituted. In place of percentile f, that decimal value is substituted. And that's what happens. Okay, let us see. Let us test all this one by one. So we had done a lot of string methods yesterday. I'm not sure if you have tested this. Did you guys tested this yesterday? Can I get an yes or no from you, sir? If you didn't test,
Yeah, Karthik. Yeah, Manohar, we did it.
yeah. If you had tested, I will continue my discussion. If you didn't test, I will give some time for you. You can test it, then we will switch to the discussion of compare to all those. See, most of you are giving me yes, means testing is done. And if it is done, then definitely it's good news to hear. I will switch to the next discussion. Okay. So I'm removing all this. Anyhow, this is there in our material or that notepad thing. We don't need these many methods now. Talk about compared to all this. Now you see, sir, I have two strings, S1 and S2. You don't need this hash code now. You can apply equals method here. S1 equals, you can see there, of S2. If both strings are same, equals returns true, otherwise false, because that's what equal does. It compares two strings, returns true if they were string, otherwise false. So I will quickly test it. Let me run this. Now you can see both are same, so I got true here. Suppose instead of Manohar, I put it as Manohar 1. Now you run this. You get false here. Can you see that? Suppose in place of equals, that's what happens with equals. It will check for data whether two strings are same or not. Excuse me. And if they were same, then it returns true, otherwise it returns false. That's what happened here. So in place of equals, let us test compare. Let us use compare. Let us see what happens. So you see there, it is taking another string as parameter. Now you are comparing S1 with S2. Let us see what happens. You got -1 here. Can you see this? Suppose if both are same, you see this. If both are same, it returns 0. Suppose if now I added 1 to first string, Manohar 1. From this we understand that this is a bigger string than second one. Now you get a positive value here. Okay. Suppose I put 1 2 here. Now you get a negative. Got it right. If string 1 is greater than string 2, positive. If string 1 is less than string 2, negative. If string 1 equal to string 2, 0. That's what happens with compare. Another important point. Compare to returns an integer, doesn't return boolean. whereas equals returns a boolean, it doesn't return integer. So this is difference between compare to and equals. There are situations where we use sometimes compare to, sometimes equals. So that's why, to get some clear idea, we are discussing about this. Okay, is that clear now? You can test it, sir. You can also test it yourself, please. Maybe you can test both at a time also. You can say, instead of compare to, you can say equals. Okay, now you can test both. And one returns an integer and the other returns a boolean. That is the difference between these two. Got it right? Is it done, sir? Tested all of you?
Manohar, when while testing for this compare, na, it's returning some value, not -1 or +1. It's sometimes returning -6, -5.
Correct, correct.
You know what is that?
It's not like every time it will return -1 and -1. It gives you the Unicode difference, Bharat. Suppose
Okay, Manohar.
string 1 is there, string 2 is there. You know that completely has some Unicode, sum of all characters, something internally will do that, and it will also do the
Okay.
same too. Probably for string 2, it will take all the Unicodes and add them and do the subtraction of string 1 to string 2 internally.
Okay.
That's why, suppose if you see, I take something like this. Now this is too bigger than that first string. Now you don't get what you are not getting -1 here, -5. So that is the difference internally. The Unicode difference between string 1 and string 2.
Mm-hmm.
Got it right, Bharat?
Got it. Got it.
Yeah, and we don't need to get into that detailing again, like how this, how it will substitute Unicodes again, how it will take that difference. That is not necessary. But the easiest thing is, the easiest part is when you do this comparison, are you getting negative or positive? If it is
I
negative,
just did some. I just did some R&D. I think it's picking up the number of characters. I think so.
correct. That's what. When you talk about this string, how many characters are there? For each character, one Unicode will be there, right?
Okay.
And probably I am thinking that first it will take all those Unicodes and it will add it, and also it will do the same for second one, and finally after adding, might be it will be doing the difference of these two, and it might be returning that difference. That's what I am thinking.
Okay. Okay.
Got it
Got it.
right?
You got it, Manohar. Thank you.
Yeah. Unicode in sense, for every character there will be one integer assigned by this Scala and Java people. Like for C language, ASCII, the same ASCII codes even here also used for Unicode. The difference is ASCII is for 8-bit representation. Unicode is for 16-bit representation. Means 16-bit in sense 2 bytes. Got it right? So that's what happens with the compare to. You get the point, right? So the question is,
Got
yeah,
got it clear.
yes. So that's the idea about this one. The easiest part is you don't need to. My thing is, we don't need to get into that. How this internally Unicodes are applied, or how it is addition is done. All that. Of course, if you are interested, it's a different thing. But this is enough for us. Are you getting positive? Are you getting negative? If you are you getting 0? If it is positive, definitely string 1 is bigger than string 2. Negative, string 2 is bigger than string 1. 0, both are same. Usually this is very useful when you are doing sorting of strings. If you are doing a customized sorting, probably not only for strings, even for objects. If you go for customized sorting on these objects, value type objects, or this data type objects, then compare to is very useful. Okay, you can override this compare to method and you can do the customized sorting there. That is a little too deeper to discuss, but still we can do it because I have done all that in even in Java as well. Okay, so that is idea. Got it right? Right. This is idea about what, sir? These methods. You can also use for comparison. You can also use this equal. S1 equal to S2. Now run this. This is for even comparison. And here the equal or equals method behaving in the same way, but in Java these are little opposite. This equal operator is exclusively used to compare a reference or address, and equals method is used to compare data. But here we are not seeing that difference because and also there is a change between string literal and string object in Java, but we are not seeing that difference in Scala. That is one more analysis thing. Okay, this is idea about this one, sir. All of you are good now. So we are done with almost strings, and the format one. Let's quickly test that format as well. I'm just testing it just to show you how it works. A quick idea, so that sometime later it might help you just to get quick understanding. Now you know when I apply format on X, this Y is substituted in percentile T and Z is substituted in percentile F, and you get a string like this. Just let's see this. Can you see there? There are 15 books and cost of each book is 30.45 something like that. Got it? Please test it, sir. Hope you got clarity. We had a discussion on this. Anybody has any doubt on this? Anybody has a doubt on this? Okay, fine, thank you. Please test it. Yeah, folks. Shall we switch to the next one? This is applying character instead of just this is an idea like how to use other format specifiers. I think we can skip this. We can just check this. Another method is formatted. Means here if you see we can directly pass string to the method itself. Can you see that? That is formatted. The difference between format and formatted is here the string can be passed to the method itself. There and also probably this should be applicable only for one variable here. Okay, because when you say x dot format and when you are saying this here, this should be applicable just for only one variable. This is another type of formatting. Okay, so would you like to test it, sir? This is nothing difficult to understand. What happens here is If you see there is an x30. On x we are applying formatted. What we are doing is x is integer here, of course. Okay? And we are applying, we are passing a string to that. And in place of percentile d, the value of x is substituted. That's what happens, nothing more than that. And here the difference between format and formatted is in format, we don't pass string. First we create string, and on top of that we apply format, and the variables are passed in the format. And these are substituted in that format specifiers. In format method, I'm talking about format. But here it is not the case. Here, if you look at the difference, here the string is coming along with the variable itself. You can see there. X is our variable, and on top of that, you are applying this format. And your string is here, and your format specifier is also inside that string. So what happens in place of this format percentile d, this x gets substituted. That's what happens here. When you run this, you get this simple output here, nothing more than. You can see that, right? I have written 30 articles. Got it right. So that's about formatted and format methods. With this, I think we are sure we have discussed almost all the very important methods of string. Still, there might be a few methods here and there. That anyhow you can explore it. That's not difficult here. And if any situation comes, if any new methods were there, we might come discuss. But probably we have clearly discussed on most used methods of string class. Okay, that's the point, sir. Will you please test it once? Then we will switch to the next topic. Now we will get to the introduction part of collections today. Okay. Okay, I am moving to the next topic, sir. Today we will take up collections. Okay, exceptions we'll do after the collections. Okay. Also, if any database connectivity is there, that also will do. Even threading is there in Scala as well. We'll do threading here also as well. Okay. So that way, anyhow, we'll talk about it. We are not going to leave anything. So now the question is about collections. Okay. So what is a collection here? Of course, there is so much here to add to this. But what we do is first let's have an idea, some generic idea. Then we will talk about examples, all that. And also, first let's have an idea about the hierarchy of collections and how it look like. We'll talk about all that. And later on, we will jump to the problems and we understand every collection thoroughly. Okay. Right. So now, what is collection and why they were so important? That is one thing. Okay. Why they were so important? Because reason is simple. Collections hold objects, not one object. They can hold thousands or lakhs of objects. Collection itself is one object, and but still collection hold other objects. So it becomes a mother object. Got it right? So Collection is nothing but it is used to represent group of objects as a single entity. That's what collection is. One thing that it is used to represent group of objects as single entity. So that is one thing. Second thing means, like, when you take an example, you can have in a collection, you can have some thousands of integers objects, or some thousands of double objects. Means double values. Every value is an object here, right? Some thousands of string objects, or lakhs of strings objects, or crores of string objects. Got it, right? So the point is, collection can hold lots of objects, and this is very much useful for us in data processing. Best example to understand collections is, you read a very large data set, okay, and that data set might have thousands of records. And what you do right now? Now you have to first store that thousands of records into one data structure. And for that, what do you use? Definitely, collections are the best fit data structures. You talk about that RDDs in Spark, that data frames in Spark, or data sets in Spark. In fact, they are a kind of collections again. Got it, right? And again, suppose you split a record and you try to store it into that data into some kind of collection. Got it, right? That is also becomes a collection there. In that way, the advantage of collections is they can hold large volumes of data temporarily, not permanently. Got it, right? That is the power of collections, which no other thing can do that in these languages like Scala, Java, C#. Even C# has collections, works are. Okay, so
Yes, yes, we have.
yeah. Concept of collections is same. Anywhere you talk about collections in C++, or you talk about collections in Java or Scala or Python. Even Python has collections, or even C#, whatever the language it may be. So, and in all these languages, collections are very, very popular, and they are very, they are very core of that language. Because just think, I have just told you, they have the capacity to hold large volume of objects. Got it, right? That is one thing. So, and all that group of objects, it is stored as a single entity. That is one thing. Second thing, so these are dynamic. Collections are dynamic. Okay, that is one thing. I'm just writing in one word. These are dynamic. What do you mean by dynamic? Unlike arrays, suppose if you talk about arrays, right? Array has a size, and you cannot exceed that size. Beyond that size, if you exceed the size of an array, you get array index out of bounds exception. Correct? We have seen such example somewhere in the last couple of sessions before. We get array index out of bounds exceptions, right? If you exceed the size of an array. But collections are not like that. You can, if they are dynamic, they are growable and shrinkable. And you can keep adding data, how many of our objects, how many of our elements you want, you can keep adding to the collection. And the size of that collection keep growing. And you can remove data from the collection. The size of the collection keeps shrinking, keep reducing. It becomes small again. It's like a balloon. Collection is a very big balloon where if you put air, it will pop up, and it will remove air, it will just shrink like that. You can just remember collection as a balloon, big balloon, dynamic balloon. Got it, right? So that is one thing. Next one. What else about collections? The disadvantage with arrays, suppose you talk about arrays, because arrays and collections are little closely related. Okay. If you talk about arrays, they're static, one thing. Second thing is, if I want to perform any sorting, searching, or any other utility methods are arrays. You don't have lot of built-in method support on arrays. Method support for everything. Most of the time on arrays, you have to write a customized logic. You have to write a logic of your own. But if you talk about collections provides lots of methods to test on this data, these huge volumes of data, which is in Spark or which is in any other language. Okay, so strong built-in method support is there here. But arrays don't have that. Okay. Next one. Most of the collections, I don't say every collection, not every collection, but most of the collections are heterogeneous. But this is not that great feature. Heterogeneous is not always good for us. Anyhow, as a programmer, we know, I can tell that, because it leads to certain typecasting issues. Okay, so array is best fit in that case, it is homogeneous. If it is homogeneous, then what all the values are same type, and the retrieval becomes easy, insertion becomes easy, comparison becomes easy. If it is heterogeneous, every time we have to see what is that value. Okay, and then as per that we have to extract it. Suppose you compare these heterogeneous objects. Not all heterogeneous are compatible. I cannot compare dog object with a donkey object. It's not possible. Got it right? So in that way, heterogeneous is a good to discuss, but it's not that useful in many cases. Is that clear, sir? So that is one more thing, of course, which is different from arrays. Got it? It is heterogeneous. So this is quick understanding about collections, like how collections are useful means the reasons, the major reasons why we prefer collections over arrays is one thing: arrays are static and whereas collections are dynamic. Second reason is arrays doesn't provide strong built-in method support, whereas collections provides lot of built-in method support. It is a very big library. Collections is a very big library. There are so many methods, thousands of methods available in collections. And for arrays, you don't have those many methods. If not thousand, at least hundreds of methods are there. Okay. This is the idea. This is the introduction. Now, let us look at the hierarchy of collections. Now, so far we have discussed about traits. Okay, we have discussed about implementation classes of traits. Right? Correct, sir? We know traits. We know where traits are implemented. Traits generally has abstract methods. And such abstract methods are implemented in a subclass. Okay. And through subclass, we override those methods. And we implement a business logic in such methods. But here, that whole hierarchy, that creating traits, creating abstract methods, overriding those abstract methods in the subclasses, the whole framework is ready, sir. We can say collections as a framework as well. Okay, a collection is also a framework. It's a framework which has lots of built-in classes and interfaces, like and traits, which has what, sir? Lots of built-in traits and classes, sir. Okay. And again, inside class, what do we have? We have methods. And this is a very big framework. Now let us see this. We'll just test here. We'll see here, sir. Collection. I will directly take you to the okay. That's the mistake. When I say collection hierarchy, it is assuming for Java. We have to tell Scala. Now you see, sir. This is simple hierarchy of collections. You see there. First thing, we can categorize collections into two categories, sir. Suppose in Scala, collections are categorized into are classified into two categories. Okay. So one is mutable collections. Mutable collections. Second one, immutable collections. Okay. You see there. We have mutable and immutable. Almost these classes names will be repeating in both the libraries. Again, mutable is a different library, immutable is a different library. Difference. Mutable objects can be modified, immutable objects cannot be modified. This is object level discussion, not var and val kind of discussion. I taught in strings yesterday, right? That kind of thing. We can change a mutable object. We can update it. We can insert it something into that. When we can, what is that? Remove something from that. We can do all sorts of things on mutable objects. Immutable objects, once you create it, that's it. You cannot update it. You cannot remove something from it, or you cannot add additional elements to that. That is immutable. Right? And if you do that, what happens? There might be two possibilities. One, it might throw an error. Otherwise, internally a new object is created. Got it right? Anyhow, we will cross check with all these scenarios. Suppose this mutable and immutable collections, probably these are classes. Both can be classes. And these are coming from where? These classes are coming from some traits. And what this traits becomes now? Because these traits has, what does it say? These traits has these two people. I'll just make a quick diagram in Paint. See here. Suppose the hierarchy will be like this in any real scenario, sir, in a real time or in any framework, not only in Scala, in any kind of technology. First, they design a framework like this. What is it? First, they prepare interfaces or traits. Okay. In that traits, they create abstract methods. And from that abstract methods, they create what is that? Implementation classes like this. They give us implementation classes. Okay. I'll just draw diagram like this. And here we have two branches. Implementation classes with what, sir? With the mutable collections. And the second one is what, sir? Immutable collections. Okay. Probably the methods, this both mutable and immutable collections are classes. Probably most of these are classes. The methods which they implement, what is that? They are coming from these traits, from this parent. These traits might be common for both. So these traits might be what? They can be partially immutable and partially immutable. We can say that. We cannot say they are purely immutable. They are purely mutable because this is a parent of both mutable and immutable collection. What do you say then? What is trait here now? It has both kids. Then what is the parent now? Is it purely mutable? Is it purely immutable? Means it's both. It's a kind of hybrid. Correct? Right. So So that's the simple analysis. We just understand this. So you get a why now you get an idea why I had discuss this generic concept. This is a common discussion. I didn't use any any technical trait names here or any technical implementation classes. I just only gave you the generalized version, just a generic idea. Okay. Now let's go and see the hierarchy. Okay. And you can see here they are giving us libraries. For mutable, there is a kind of library. For immutable, there is another kind of library. You can see that here. Okay, we will talk about them. See here. So these are all, if you look at this, these are all what probably most of these are the top level things, this traversable, iterable, sequence set map. Okay, some of these were traits here. Traversable probably should be a trait, iterable, and some of these are sequence set map, indexed sequence, linear sequence, sorted set, sorted map, bit set. Probably this should be implementation classes. Okay, so 1 minute. Oh, you got it right. Can you see here now? They only mention here. We don't need to worry about it now. So which are traits and which are classes? They will just otherwise you can look into the API as well. You don't need to no. We don't need to worry about it. You can see there now. All collections are there in which package here? Scala.collection. And sub package is mutable and immutable. Just now we have discussed. And generic one more. And mutable, inside mutable package, what do you have? All mutable classes are threads. Immutable, you have all immutable classes are threads. Okay. And you can see this root collections in package. Root collections means like like this traversable something, fewer root actually. These roots are both. I told you just now, right? Roots means the traits is inherited to both mutable and immutable collections. Then it becomes what? That is having a feature of both. You can see somewhere that point is also highlighted here. Okay. You can see this root collections in package Scala.collection defines the same interface as immutable collections and immutable collections in package. Okay, here. And also one more thing is the advantage of this is there is something called which we use a word called backtracking. Means it is fit for both this implementation classes in the immutable collections and implementation classes in the immutable collections, right? So that thing what we call it as backtracking. The one which you have implemented in the subclasses are having a common signatures in the this traits. Got it right? Okay. 1 minute. I just want to give you a quick analysis, which are which are traits and which are we can just quickly test it. Traversable is a trait. You can see this, sir. Okay, this is a trait. Okay, no issues. Now, iterable should be also a trait. You can see in the libraries. These are all APIs. Sir. This is also a trait. You need to get all this information, sir. As a developer, you should know all that. Click on sequence. Sequence is also a trait, sir. Probably. Then this should be list of all traits, if I'm not wrong. But anyhow, I would like to quickly see indexed sequence. This is also a trait. Okay, and you can check all remaining which are traits or which are classes here. Okay, and then string builder. I think I didn't discuss this. We'll talk about it as well. And iterator, probably these are all traits, sir. If I'm not wrong, even let me check range. This is a class, sealed class, they were saying. Okay, we didn't discuss the concept of sealed. We'll check it, sir. What is that sealed again? This is final. You know this. Final means we cannot inherit. Vector should be a class, no doubt. This is also a class. You can see, right? Traversable, iterable, probably sequence, set, and map also should be right, sir, if I'm not wrong. Because we have checked here, right? If you look at this pointer here, when we click on this sequence, this is showing as a try. Means if this is tried, then probably what is it? Even this the other siblings here, set and map probably will be tried, and these all at low level. This might be implementation classes that we have to cross check once, because there might be so many classes, sir. We cannot be sure which are classes, which are interfaces here. Now this should be more clear for you. Probably this black color things should be classes, and green color things will be interfaces. Let us see it now. Probably that should be true in some ways. See, sir, to get the difference, all collections and package, one thing, and also they will update here. Somewhere I had seen this point. Yes, can you see? Green colors are traits, black colors are classes. From this, we should understand what is it. You can see all these are traits: traversable, iterable, okay, map, okay, all this. But anyhow, we discussed this hierarchy, level by level, sir. You don't need to worry about it. But you have to understand one thing from this hierarchy. This is for immutable. This is an immutable hierarchy. Probably the concept is same for both immutable or mutable. And you can see here, sir, traversable is there. From traversable, you get iterable. And this has two kits, set and map. And set has so many kits. Okay, no family planning here. Has set, list set, sorted set, tree set, bit set. Indirectly or directly, these are all the kits. Okay. And map also having multiple kits here. These are all implementation classes except sorted map. We'll talk hierarchy by hierarchy. We take only set hierarchy and discuss. We take only map hierarchy and discuss. And sequence. Sequence has two kits. Immediate kits are indexed sequence and linear sequence. And there are so many implementation classes. Lists, vector, numeric range, string, and stack, and stream, and queue. These are all IMPL classes, implementation classes. So this is for immutable hierarchy. What is all this? What is difference between set, map, and sequence? Why these many divisions, classifications were there? Why do we need all that? If you ask me, we'll discuss level by level. First, we'll take discussion of traverse and iterable. Then we'll talk about this left side hierarchy and right side hierarchy and middle hierarchy separately. Exclusively one hierarchy we will discuss, so that you'll get all the differences as well. What is somebody ask you a question? What is the difference between set and sequence and okay, and then map? Then you can answer it. Definitely there are differences. Maybe if you want, in just a minute, I can give a quick briefing. Sequence is more or less like it's like it is an indexed data structure where you can have duplicates here, and also what is it is you can what is that? This is dynamic again, and also we can add few more things, sir. One is it is indexed data structure. Second one, you can allow duplicates, and third one, insertion order. One more thing, definitely as it is indexed data structure, insertion order is preserved here for sequence. Set is right, you have learned it in school days. Set is, it doesn't allow duplicates, no duplicates. Insertion order is not preserved here. And then one more thing is what I told three things, right? It is not indexed data structure. Again, set is not indexed. And even map is similar to set. You can see here, if you have hash set, and right side you have hash map. If you have list set, you have list map. If you have sorted set, you have sorted map. If you look at that difference, the classification of set and map are little near, they are little what do you call, comparative. They are correlated, little correlated. The point is, map is something which stores data in the form of key and value pairs. That is the difference. Other than that, map and set have all a lot of common features. They share a lot of common features here. Okay, what are the features? What we have said, probably those features are even there with map also. In fact, internally map is built by using sets. Sorry, set is built internally using map. Got it right? So they share some common features here because they are almost similar in many angles, in many things. Okay, but sequence is a bit different. Now, in this 1 or 2 minutes discussion, you should get some quick idea. Okay, if you want some indexed data structure, if you want some duplicates, and if you want insertion order to be preserved, then we prefer sequence or its implementation classes. If you don't want duplicates, if you don't want insertion order to be preserved, and also what is that? And one more thing is, if this is not indexed data structure, then we have to follow set. You want data in the form of key and value pairs, then you should use map. So this is a clear difference between these three are hierarchies. Got it right? And we talk more on it. We will practically see the difference of everything there. Okay, I'm just giving you in a quick and in a nutshell, a quick brief discussion. Brief means just high level. Now this is mutable. Now if you see, likewise what we have in immutable collection hierarchy, even here it is also having so many similar classes, but few extra we are seeing here. Okay, now again iterable has kids here, 3 kids again, a map kid and set kid and sequence kid. Okay, a fruitful marriage for iterable. Okay, so many kids are there here. Again, what happened? Map has so many kids, you can see there, and there are so many new classes added here. Okay, hash map, weak hash map, linked hash map, list map. I'm just giving a quick high level discussion. We will talk about it once we jump into this topic from tomorrow. And similarly, set is also having few more extra classes here compared to the other. Some differences are there. Few classes, whatever is there in immutable, might not be here, and few which are not there in immutable are there in mutable collections. Okay, and sequence, you can see it's a little big hierarchy here compared to that, if I am not wrong. So that's, but right, sir, after looking at this hierarchy, you don't need to worry or you don't need to feel bad here. Okay, why? Because if you really know how to play with one collection class, the concept is it is same for all collections. We can play with the other classes in the same way. Got it right? I don't think this is difficult at all, because the way we work with all collections is almost similar. Got it right? You need to just only get an idea, like how to, what is that, what are the differences, what methods are there, how to apply those methods. And also, once you just get an idea about how to implement for one class, it is same for almost all other classes in one hierarchy. Suppose you learn hash map. Weak hash map is almost similar to hash map. Linked hash map is almost same. Okay, even other maps will be almost doing same with some differences. Of course, there will be few differences. Okay, but the basic thing is same for all these classes. Okay, similarly same for set. If you know about hash set, if you know how to play with hash set, it is almost the way you program it same. There will be internal differences. That is a different thing. Okay, for a programmer, if you know how to play with it, that differences doesn't matter. You can understand it quickly. And sequence, probably same thing here. If you know how to play with list, then it is playing with other things is almost same. It's like as simple as if you know how to drive one bike, you can play with other bikes as well. But the only difference is the dynamic changes. We should understand that. That is the point. Okay. Got it right, sir? So I would, I thought to show you directly the hierarchies and how it look like, and what would be the collection framework look like. I want you to see here. So I brought you to this website so that you also have that a clear view of every hierarchy and how it is working, what are these traits, what are these implementation classes, okay, all this stuff. Do you get it now? Now, right, sir? All of you are good now? Is it clear, sir? From tomorrow, we jump into the discussion. We start, discussing from traversal. First, we'll start with the traversable. What methods are there in traversable? Then we will come to the iterable. What methods are in iterable? And then we'll start discussing about the major core interface, traits: map, sequence, and set. These are core interfaces. And after that, we'll talk about their implementation classes. Okay. If not every class, at least the very important, all the important classes, implementation class. At least we'll talk about 15 to 20 classes altogether. Got it, right? And also we see the implementation, how this programming works here. We will also see so many scenarios, use cases. Okay, right. So this is the idea about what's a collection, introduction, and the hierarchies, and then all that stuff. Anyhow, this is open here. I just directly gone to the website. Now you can also go to the same website or some other website, whatever you like. I don't have an issue. Okay, because I thought this is the something fundamental. I'm seeing good information here, so I'm coming to this just to show you. Okay. So any questions, sir, on top of this discussion? Any questions?
No, sir, we are clear. Thank you.
Thank you. From tomorrow, we will get into the detailed discussion of everything. We will do workarounds. Make sure that we are really good with collections. Got it right? Thank you, sir. We'll meet tomorrow.